Hey math kids, today we're going to talk about interpreting functions that arise in applications. We're in section 2.8a. Alright, so this assignment actually has a really big in-class portion, and so that's what I'm going to go through real quick. It'll be a shorter version of that. So we have a parabola. Put it on an axis. We have a parabola. Like this. Now, the point that's like the lowest point on a parabola that's oriented like this is called the vertex. And here, I'm going to just talk about all of these. So we have the vertex, it's just that lowest point. It's the most extreme point, in this case the lowest. If I have a parabola like this, the vertex is actually the highest point, so it would be something like that. Okay, now right here, these two dots where it crosses the x-axis would be the x-intercepts. And then the place where it crosses the y-axis would be the y-intercept. And then we also have a concept of increasing and decreasing intervals. So we're always going to read from left to right, just like when we read a book. So if we're thinking we're on a skateboard, and whether we'd be going, I don't know why I can't draw that there. Okay, so if we're on a skateboard and we're going down or up, that's how we know if we're increasing or decreasing. So on this function, we actually start by going down. We're going to go down until we hit the vertex, and then from the vertex all the way to infinity, we are going to be increasing, because from there to there, we would be traveling uphill. So for example, if the vertex was something like 1, -5, the x value right here is 1, and so we would say that we're increasing from 1 to infinity. Once again, that is increasing interval. Now, decreasing interval works very similar. This time we're starting out going downhill until we get to the vertex. And so we're going to start at -infinity and then go to the vertex, which was the x value was 1. So this would be decreasing interval. And that's about it on that. Now, something that's important to remember is that increasing and decrease, or just anytime we hear interval, we're going to think x values. Okay. Now, moving on, we're going to find a maxima or a minima. So we have Maxima Minima with the A on the end. So these are also called local max. It's like local max, local min. And what it means is if we're not considering like going to infinity as our max, because we just go on forever. We want to know a place where we like go down and then come back up. So right here, or we go up and come back down, and so right here. So this one's going to have a local minimum because we go down and then come back up, or a minima. So these ones are relevant to this. These ones we would just say none. And we just want to write the y value. So we said the y value is at -5, so we just say y equals -5 on that one. Okay. Now, axis of symmetry, that's just going to be this line that cuts the parabola in half. So this is the axis of symmetry. And then we also have end behavior, which is, let's see, I'm going to draw a different diagram. So if we have just a parabola that looks like this, as we go to the right, here, I'm going to color code this actually. So as we go to the right, our parabola goes up. As we go to the left, our parabola also goes up. So it's kind of like the skateboard thing. If we were skateboarding from right to left, we were traveling the blue direction, and eventually we would be going up. So it's what we do at the very end of the parabola, so we're going up. If we're going in the pink direction, eventually we're just going to keep going up. And so the way that we actually write this is we ask the question, we say, what happens as x approaches infinity? So that's what the pink is saying. And the answer to that is y approaches infinity. So what happens when we go to the right? We go up. Now the other one is, what happens, so we ask the question, what happens as x approaches negative infinity? Or what happens when we go to the left really far? And the answer is, well, y goes up, or y approaches infinity. So hopefully those, the color coding helps on that. Okay. Oh, and then we also have positive and negative intervals. So I'm going to come back up here. So what that's referring to is if we have a parabola, we want to know everything that's above or below the x-axis. So if we're above the x-axis, this is considered the positive interval. If we're below the x-axis, that's considered the negative interval. And we're going to write it in interval notation like we did with the increasing and decreasing interval. So we just want to know which x values put us above the x-axis or which x values put us below. So I'll do more of that in the context of a problem. Okay, so let's look at a problem like this. So x squared minus 4. So going through this, just graph it. So either graph it with a calculator, graph it by hand by plugging things in, making a table, or you can just kind of move it. So we know x squared would look like this, but then negative 4 would put us 4 below. So we're going to go like that. Okay. Now, I'm going to show you on a calculator though, real quick. Because we want to know where our x-intercepts are for sure. We know the y-intercept, but I'm just going to go x squared minus 4. Graph that. Okay, so we can see that we cross at 2 and negative 2. So on my graph, I'm going to look like this, like that. Okay, so it asks for a bunch of things. So I'll go in the same order as your assignment. So x and y intercepts. So x-intercepts, we have one here and one here, and we have a y-intercept right here. So the x-intercepts are negative 2 and 2. The y-intercept is at negative 4. And then increasing and decreasing interval. So from the vertex right here, we're going to go uphill. So our increasing interval is going to be from this x value all the way to infinity. So increasing interval is going to be from 0, because that's the x value of the vertex, all the way to infinity. Now the decreasing, where we're going downhill, we start off So decreasing interval, we start off or going downhill or negative infinity. So from all the way over here to here, we're going downhill. Once again, we start going uphill at 0, and so that's where we stop going downhill. So our decreasing interval is from negative infinity to 0. Now we need to do a maxima or a min, so I'm just going to say max or min. So since we go down and then come back up, we have a min, and we just write the y value, so y equals -4. And so for the max, I'm just going to say none, because there is no maxima. Okay, now it wants to know the axis of symmetry, so it just wants to know the x value of the vertex is actually always going to be our answer on this one. So the axis of symmetry is x equals 0. End behavior. So right here and right here is really where we're looking, but as we go to the right, so here, end behavior. So we ask the question, as x approaches infinity, or as we go to the right, what does y do? Well, in this case, y goes up, so y approaches infinity. Then we ask the question, as we go to the left, or as x approaches negative infinity, our function also goes up, and so y approaches infinity. Okay, so all of that together is end behavior. And then we have positive and negative intervals. So positive interval, negative interval. Okay, positive. Actually, in this case, negative is easier, so I'm going to start with that. So negative is just what's happening below the x-axis, or like which x values put us below the x-axis. So it's going to be from this x value to this x value, or from -2 to 2. So from -2 to 2. Once again, these are all x values. I know this looks like an ordered pair where you're used to x comma y, but these are actually just, this is actually just saying from -2 to +2. So everything below there is going to put us below, or sorry, everything in between those 2 points is going to put us below the x-axis. Now, above the x-axis, we have 2 pieces. We have this piece and this piece. So we're going to go from negative infinity until we get to -2. Then we're going to do a union symbol to tie them together. We'll talk more about that in a later unit. For now, just know that's how you connect 2 intervals together. And then all of this is negative until we get to 2. And then we're going to be positive until we get to infinity. So it's the positive interval is all of this. Okay. Now I'm going to do one more, but this time it's a parabola